This is number 16 on the graph. It's written in standard form. I'm going to put it into slope-intercept form first. 8x minus 5y equals 15. We always move the x term first. We do that by adding or subtracting. Positive 8 minus 8 is 0, so I'm going to subtract. That negative sign with the 5 comes down, so negative 5y equals negative 8x plus 15. Divide by negative 5 each spot. So I get 1y, or y. Negative 8 divided by negative 5 gives me a decimal, which I can leave as a fraction, positive 8/5, and then minus 3. So my y-intercept will be at negative 3. 0, negative 3 is my y-intercept. I know the worksheet asks for that as well. My slope is up 8 over 5. So go up 8. 1, 2, 3, 4, 5, 6, 7, 8 over 5. And then I can do my best to connect those lines. For my x-intercept is close to 2, but I don't think it's exactly at 2. So I don't want to guess and say it's at 2. It's close. So this is where I need to algebraically find my intercept. If I want the x-intercept, I need to let y equal 0 to find it. So I take the original equation and I say 8x minus 5 times 0 equals 15. 5 times 0 is 0. 8x minus 0 is 8x. Then I'll divide by 8 and say x equals 15/8, which is 1 7/8, or 1.875. Double check that. So my x-intercept is 1.875, 0. I can use a decimal or a fraction because the decimal is exact. So that isn't at 2, it's at 1.875. If you were to say 2, you'd get it wrong because that's close, but not the exact value. If I wanted to find the y-intercept from my original equation without converting it to slope-intercept form, I could find my y-intercept by letting x equal 0. And so I could say 8 times 0 minus 5y equals 15. 8 times 0 is 0. 0 minus 5y is negative 5y. Divide by negative 5 on both sides, and I'll get y equals negative 3, which I already had, but that's just another way to do it.